Hello, I stopped my lecture in a very critical point last time, saying we have various types of things here. So, one of them is things about geometric primitives. So, in these primitives, the common primitives are the points, lines, line segments, planes, because why the word line and line segments are shown is generally lines in general mean not necessarily a straight line, depending on mathematical what do you call, how much of thing people do for defining those things. At one point of it, line is considered as the shortest distance between 2 points, something that line joining them at all. Line segments could mean something which is a little longer and arbitrarily shaped. Then you have planes. A plane is typically, if you recollect last time, something in which several points can lie together in a coplane. The moment you have a flat sheet, then I have taken you an example of this mouse pad. Remember the mouse pad, it is flat. So, if you look like this here now, generally it does look somewhat flat both directions, but now if I connect these three, you see here a triangle forms. Typically this triangle is planar. So, coming back to a common example, if you have a three-legged stool sits stable because they can sit in any plane. But if a four-legged stool, we have a problem that three of them will touch and the fourth one will be not touching at all. This is the whole basis of mesh generation. A mesh consists of very elementary triangles. So, then I have shown you, rather I have mentioned to you about how a ball is made. You can build a ball out of hexagons and pentagons, and then we have the famous buckyball, and then we have now the C60 what do you call carbon atom and so on. All of these, if you see, it is all based on basic triangles like this. So, coming back to my this display here, you will notice that we have triangles, arbitrary polygons and quads are the ones that are the common primitives. You see here. So, we have here triangles, arbitrary polygons. Now, we have this about the spline curves. I will get back to it later. It just means if you have 3 points, you can have a start and end point, and if this is a start and at this point, we can put another the what you call point and pull it up, by which a smooth curve can be drawn to that. That at the moment I will just call it a spline curve and leave it here. I will come back to Bezier and I will come back to NURBS and so on like that. Next, if you come down, you come to other things here. You have seen this? Spheres, cubes or prismatic objects. Then we have this toroid. Toroid is a surface with a hole in the middle like a donut. So, I think that is enough for you to talk about. Now, similarly, we have a cylinder. You see here exactly, the cylinder is given here. This is the good old tin can. So, I think it has been forever, as long as we like, it has been here. Next, we have famous pyramids. So, pyramids are a non-stop, it's fascinating, tens of thousands of years. So, the very simplest pyramid can have 4 faces, where all 3 faces are triangles. Next, we have triangular meshes, polygon meshes. So, in the case of a triangular mesh, this is what I was trying to tell you at that point. Can you see this? even a smooth surface eventually has been to be broken into triangles, and depending on your CAD package and depending on your way of representation what you like to see, it can be smoother or coarser. So, polygon meshes same thing, a triangular mesh and okay. So, if you notice here, the very basic things are these vertices, then we have the edges, we have the faces, then we have the various types of polygons, and then we have the surfaces. Why am I, what do you call, presenting all this? It is that unless you know a little about it, often when you get stuck with actual solid modeling or trying to make any product, you will be wondering why things are not behaving the way they are expected to. What was there in your mind? You had some concept and then you try to model it, and then suddenly you will discover that these things do not work. Again, get back to the presentation. You have seen these vertices are the corner points which are not joined, edges are where two of the faces meet, and faces are those elemental triangles we are talking about. When everything is flat, there is no problem, then it becomes various types of polygons here. You see here, for example, this is a planar polygon. By definition, there will be polygon, and surfaces are same thing. When two of these things are joined together, they form a surface, and finally in the end you have the full fledged prism. It is for you to understand what it is. So, my suggestion is go through that, just go to the, I mean any place, go and then try to read all these things, saying so many things are there. Right now, no, it will be too much. Mainly, what is important is all representations or everything will only be this. We have, there is a list of all these vertices which are joined together and it is presented to you. So, at one extreme, you have seen this here, face vertices and so on and so on. You, to satisfy your this thing, you can just read it at your own. You will have a chance to come back and then probably get back to these things. Now, look at the other monitor which I have there. Sir, can you connect this monitor? These are typically from one of the software which is now freely trial versions which you can download. It has limited thing. So, if you come back here, no, the very basic solids as you see are, there is a cube, prismatic cube, there is a cylinder, then there is a sphere, and then in between something which depending on how you look at it, we have a cone also. So, now if you look at these things, I am sure some of you would have recognized this. Now, this one is not a simple primitive, what do you call, it does not directly come into the primitives. You understand? Now, this looks like a very complex solid. So, I can look at it from, in this all the faces I am able to see. Now, if you look back at this monitor here, you have seen this has been taken from here. I am sorry for what do you call, well, I am not strictly speaking, I am just use it as a common practice, and I am not being what do you call, it is not part of product placement. It is just that it is there, that is all I can say. So, this is typically This sort of things you would have seen here. As you notice here, there is nothing, there is a base, the base here, then there is something else, a small curve here, and something which is directly fitted in this. This is typically the simpler of the objects what we see around us. And why this particular shampoo bottle I have chosen is that if you have to cut the shampoo bottle, you will notice that of course all the shampoo will leak out, ignoring the shampoo leak out. If you cut the bottle when it has come from the original thing, what you notice is it has only a thin shell. It is not a solid in that in the strictest sense that it is how to tell, it is full inside. It is not a full inside solid, it is just a shell. You have a surface again all around, all surfaces are joined together, and important thing is this is exactly how it is produced, a blow molded component. They just generally take a small former, put it in a mold and then inject some gas, I am not very sure about it. You can just take it at the moment, can you take it as normal little clean air, otherwise nitrogen, occasionally carbon dioxide. When you push it inside, the whole thing fills the mold. So, typically, ideally this sort of, if you see these things, they are all best examples of the solids, but not necessarily a true solid. You understand? No, it is not a filled solid, it is just a blow molded component. Typically, most solid modelers have this in the thing, and surface modelers have only this, nothing else in this. So, I will try to show you something. Now, I am sure some of you have seen this. This is a very common place. MP3 player. So, I will notice this is typically, if you see, this is how most of the products, electronic products, anything what we would like to make, all come into this category. Why I have selected this is it does not have a very complex surface. What it basically has, it is a cube. In fact, they have made it intentionally as a cube. So, in the front there is a what you call a small gap has been made, and they have attached a mask here. You have seen this, no? And this is, I am not very sure if it is actually functional, it is just part of making it look a little more attractive. And at the base, if you see, basically they are nothing but a row of LEDs in this. Okay. Then we have the display here, and then we have a window and all sorts of technical things which are here. You understand, no? So, when you cover it, you come here, and now this one I will come back to it. It is actually a waveform which typically if you overdrive an amplifier or anything, there will be a tendency for things to clip. So, probably they have found out that this is attracted people, and then they have put it. Now, inside this, if you see, it is nothing but a cube in which they have removed various things here. Can you see here? So, at the back of it, you see here, this is the mask. That is, these areas are clear. Okay, on that they have done various types of printing and all. Why it is? Why I chose this particular thing is, it's a very simple prism, and on the prismatic object, first time itself when you start your design, the designer, without even having to build any particular prototype or anything, or a very elaborate expensive prototype, all that they need to do is make all this like this, and if these things are approved by your team, not by the customer, not by the what you call sales people or anything, your development team or whoever is the core team approves it, now you can go ahead and develop it, and your effort in creating all this has not gone waste, it is with you for life. If you remember previous, I think 2 lectures behind, I showed you the various type of these modules and all these things. So, this is actually built one, it is not come out in order. So, you can see those things underneath, you have seen that this is the starting one, okay. And this is where I wanted to tell you once more again and again, all you need to do is have a graph sheet underneath. This is taken with an old our printed circuit board system, by which we used to have the 1.27 millimeter grid system. Even today, most what do you call printed circuit board or anything, the pads are all placed on 0.1 inch grid. It has gone all the way to 0.05 and 0.025 grid pitches. So, you have this thing at the bottom. Okay. In this particular case, in fact, we have selected a millimeter grid, because unlike the printed circuit board, here you will have all our dimensions and all are based on millimeters. Most of the world uses millimeters, and even the what you call US system still uses both. That is, you have inch variant, but in the brackets usually millimeters are there, and in the inch decimal inch is shown, because it looks like some machine tools and all that is easier to program in the decimal system. So, I just wanted to show you this is the base, then this is the completed project, and this is actually taken from the, I mean, one of them, I asked one of my friends who has been good enough to damage his device, and see, he is curious enough to see what is inside. So, I have seen that. So, typically, even if I were to take this is basically a simple rectangle, another rectangle, okay. And this is the basis of most of the products that we have, and except for very high end things like cameras, most printed wiring boards and all continue to be plain. You do not have 3D yet, and that plain one, if it is a flexible device, wherever the connectors and all are there, that is bent, or it is still essentially a plane which is bent, not twists are not yet there, not yet ready, except in very expensive thing. Now, coming back to my this picture, you will notice here that this is the original thing, and my colleague has been good enough to pry it open, separate it, and after separating it, you see here, this is where the sequence of operations. So, whenever you do solid modeling, I have jumped a little saying how come here is a different thing. This is, I just wanted to tell you that it is worthwhile doing your things in CAD, and you do not need to depend on anybody, you can do it yourself. So, it is open, and you see what you see inside. It is nothing but a empty, what do you call, I am not very clear whether it is a fully molded thing. Okay. On one face, you have one more shelf like thing. What it does is, this is enabling this flat printed wiring board and all to sit here. This is where we have the true example of how to build on genuine solid models. There is a thickness here, and the one at the bottom, if you see, just to accommodate this, I do not know, maybe various other devices and all, they have made a small depression here. So, If you had started your model like this here, you understand, no? The external appearance is here. At the bottom, we have all this USB and all these things which are coming here, including probably this is a headphone and this is the printed wiring board on top. Now, this is the only active part of it, you understand, of this whole system, no? This is the only active, what you call, circuitry portion of it. From here, there are places here, probably 2 of the leads go to the, 3 of the leads go to the speakers, 2 of them go to the battery and the charging device. See here, it looks quite good. And on one of the faces, when I open it, I notice that they have just reduced it to half the thickness, so that a small speaker can be introduced. Now it comes to little acoustics that does not cover the acoustics. Now would you like to have an infinite baffle, or would you like to have a ported baffle or anything? So on this side, I do not know if taken a picture, there is a small opening which slightly improves the low frequency response. Okay, this is just what I wanted to show you in this. You have seen this? We have this beautiful various types of thing, and the core part of it is still a very, very simple solid model. And based on, I am trying to bring this back to you, saying initially when you have a concept, you can freeze on all the dimensions by directly starting with these various things like this. And I have brought you back again to the, what do you call this, a shampoo bottle, which will show you basically it is nothing but a shell. So this is a very simple shampoo bottle. So we have a ellipse, this ellipse has been extruded and something has been cut, and this is probably the simplest thing, easy to make, and some people may even buy it. And however, when you actually want to make real life things, probably this type of things are very much involved. So here what I thought I will show you is, you have seen this, there is a beautiful, there is a surface here, there is a surface here, and the surface is not a flat surface, it is a very complicated surface. And I was just showing you the thing, though this is a grey colored dull product, a little bit of light, and that is what you see. This is where whenever you actually do solid modeling, you have to spend a lot of time and then see that the correct type of look is presented. And there are computer experts who can make photorealistic rendering of any project. So if you give a basic project like this, and if you ask one of the commercial artists, no, kindly make a package and all this, and they will make something which looks real, really real, meaning very difficult to ignore that, saying that is not a, you understand, no, it will be very, very difficult. Right now, let me watch for it, saying this is actually a real thing. I have taken a full shampoo bottle, and of course my people did not allow me to cut it. If they had allowed me, I would have cut it and shown you. Now, if you come back to my other monitor, I will show you this. You have seen this here, these are the very simple, most simple geometry primitives. This I had shown you earlier, saying instead of showing you that cube of a speaker, I thought I can make something a little more interesting. I made it a little more interesting by taking a cube, joining the midpoints of the edges and trying to fit a speaker on top of it. Now if I give a rendering onto this, one of the first things you will notice is, see at the back of it. Now I want you to recall that edge I have shown you. So I have that edge here, that edge is the one that this edge is the one that catches the highlights, and then you will see it like this. This is a relatively simple object, and just to what you call create a little bit of interest, as I said, I joined the various corners and try to show you this thing. Now, if you go to any of the tutorials based on these things, you will see those things everywhere saying we have these primitives, how to use these primitives and learn at the first time. So, I will try to show you a little about yeah. Very interesting thing here. You have seen this, I am sure quite a few of you would have tried this or you would have been fascinated as a child. See, we know what we have here. A globe has been taken and we try to split it such that you can make a nearly continuous model of it. So, actually if you see these vertices here on the topmost point, no, that poles, there are, it has been split into 8 sectors and the center has been offset here, so that it will not, what do you call, I will just show you just once again, no, to see if, see here the real life thing is going to be, a paper can always be cut in these things, and the small thing that has been added here is the tab which is used for sticking those things, and depending on how well you can manage these things, beautiful things like this can be easily created. I will come here and show you, because I have the internet connection here. See, a real life earth is going to probably look a little like this. So, if you are one of those people who enjoy making this is the real life earth. If I click on it, no, part of the earth is going to look like this. Now, if I take this and try to develop it like a orange peel, start at the sphere on top and cut all the way across like this all around and make 8 cuts here, it is very easy for us to develop this into a beautiful project. And made my bad luck, when I tried a little earlier, it came and little, you have seen here, various ways of developing it is there. In this case, if you remember, this is what I was telling you, saying any particular shape, you can always make a globe. One of the easier thing is to cut it along like this. You understand, no? These are all small things. Otherwise, this is the picture I tried to show you. You have seen this? In this case, the only difference being we have these things which are cut here, and chances are you are likely to damage it a little. So, the one that I have shown you is offset by 1 pitch. When you offset it by 1 pitch, and depending on the resolution you take here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, in this case 11 sectors have been 12 sectors have been made, and with this nicely beautifully you can develop a beautiful globe based still on a surface model. So, even the globes that you see there are probably simple surface models. So, I thought you should you will probably enjoy looking at this. So, I have in fact used this. See this here, here they have provided this tab here as a small tab. This is very essential, which I have missed in fact. You have seen this, no, small tabs have been kept here. And one more thing is, if you make a simple arc, you are going to have a little problem. So, physically on the globe, you need to measure this, saying what is the surface this thing. When I showed you the earth system, when I showed you this earth thing like this is best actually. You have seen this? It is not easy. Anyway, you can go through, I hope it comes. Yeah. Now, if you get this point, those arcs what you see there, they represent, if you cut the top into 12. So, you have a to make it convenient, 12 is easy because you get 30 degrees. So, at this point you have 30 degrees, however here this is from the horizontal, this will be 90 degrees. So, you have the arc where this side is 90 degrees, where this side is 30 degrees, and the length of the arc should be from the pole to this, that is where the small difference is there. So, there are actually programs which will help you develop these things, given the diameter of the sphere you want and given the diameter of the the location of the poles and various other features, it is possible for you to transfer all this directly to this. I have kept it at a level where it is a little playful and little for you to get involved. So, those of you who are curious can probably try this. It is not impossible to make these things. So, there are, coming back, you have things which are made with hexagons and pentagons, and other extreme is the C60 full range model. You have seen this? This is a real beauty. This is a very, very fantastic, really cute arrangement. See here now, this is what I was telling you, what looked like a very simple and what you call play item, suddenly it is very, very professional. So, you have hexagon, 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 everything sharing edges with a pentagon in the middle. The moment you have a pentagon in the middle, that thing will naturally fold over. So, any of these hexagons, if you say, if I take this hexagon, it shares an edge with a pentagon here, hexagon, another pentagon, hexagon, pentagon, and another. I am not able to make out, just a hexagon or a pentagon. So, when this thing happens, you have a perfect ball. Now, why I am showing this is, actually the elemental portion of this is still, this seems to be best. It is still a triangle. If you take this pentagon, take the center and join it here, this is a basic equilateral triangle. So, this whole Buckminster Fuller globe actually exists in nature, which I do not know how it is. So, you see everything which is any complex shape, any complex surface can easily be built up of small triangles. That is all I thought I will show you, and this is again the basis on which your 3D printing takes place. After you have finished building a model, when you want to make a 3D file, 3D printable file, you have to export it as a STL file called stereolithography file, and stereolithography file mentions everything in the form of small triangles like this. I will continue this next time. because I think this is about so much you can, what you call, anyone can try to understand. My suggestion is, yes, I have an accent and difficult to follow. My suggestion is, go back, watch the video again, wherever I have given links like that to the World Wide Web, go and follow them up. Then I expect various things will fall in place for you. And I just wanted to tell you there are enough softwares which are available free of this thing for a trial version, and they are enough for you. However, if you are an institutional person, like if you are a student from an engineering college, most of them, the vendors have permitted an educational version with limited licenses, so that you can work in the lab with that. So, get started and start working on this. Thank you.